Hello everyone, this is Ray PCB, your trusted PCB partner. Today, we will introduce the commonly used commands for operating the PCB footprint library in KiCad. The PCB footprint library is the mapping of physical components onto the PCB. You cannot arbitrarily assign footprint dimensions. They should be drawn according to the precise measurements specified in the component datasheet. The integration of the component library and the PCB library serves as a bridge connecting the relationships in circuit design to the actual physical circuit board. It is necessary to create a PCB footprint library. So, let's first open the project. Double-click on the footprint library editor to open the footprint library editing window. If this is your first time, you need to pin your custom library to the top. Pinning it makes it easier to create and select components here in the future. Then select our library. Right now it's empty, so double clicking it won't display anything. We need to create a component first, otherwise the place button will be grayed out and unusable. So let's start by creating a component. At this point, you'll see the component name here, which we can edit later. At this point, you'll see that the place button is now active, and there are many placement options available inside. We'll introduce some of the placement options that we commonly use. First, we'll place a line. When you do this, your cursor will turn into a large crosshair. Before we usually start drawing, we set the line properties first. Press E on the keyboard to bring up the line properties dialog. The main thing is to select the layer. Usually, when we draw lines, it's mostly to outline the package in the library, so by default, we select the top silkscreen layer. As for the width and height, we generally don't pay much attention to them since they'll adjust automatically as we draw. The line thickness can be modified, but we usually leave it at the default setting. Now we can start drawing. Click the mouse once to drag the line, and when you reach your destination, click again to continue drawing. Here we'll simply draw a rectangular frame. When the lines are closed, it will automatically finish. Right click to exit drawing mode, and now you can see that the line has been drawn. If we double click, we can still see the property box for the starting point. If you need to fine tune the starting point, you can adjust its value here after drawing. Generally, there's no need to change the line width. For the line styles, select solid if you're drawing a straight line, or curve if you're drawing a curved line. As for the layer, it's the same as before. If you're drawing the outline dimensions for a footprint library, the default is to select the top silkscreen layer, so the outline will be drawn there. After drawing the outline, let's take a look at how to place pads. After selecting and choosing to place a pad, press E to bring up the pad editing window. By default, the first option is the pad type, which is set to SMT shape. You can also see options like through-hole, four-edge connector, non-plated, and various other types. Choose the pad type according to your specific components. First, let's look at the through-hole type. Through-holes are used for soldering through-hole components, and they will display multi-layer drilling. Next is the pad number, which, just like in the schematic, needs to correspond to the pad's number. Then comes the pad shape. Here you have options like round, square, oval, and various other shapes. The choice should be made based on your actual requirements. If you choose a round shape, you can select the pad size, which determines the overall size of the pad. Since this is a through-hole pad, it also involves the size and shape of the hole. Here, the default hole diameter is 0. If we set it to 1 millimeter, you can see that there will be different styles of holes. If it's a slotted hole, you need to set 2 parameters. If it's a round hole, you only need to set one parameter. These are some of the common types of pads we encounter. If it's an SMT pad, there aren't so many options, just the shape and size. If it's square, you set the length and the width. If it's round, you only set the diameter. So let's say we place a round pad. Just click like this, and it will automatically increment the pad number. So you can place multiple pads as 1, 2, 3, and so on. After placing them, you can adjust their positions as needed. Once you're done placing, press ESC to exit the pad placement tool. Next, let's take a look at the placement rule area. After you select any area, the properties window will pop up automatically. You don't need to press E. First, this area needs a name, so we give it one, and here you select which layers this area will apply to. Choose according to our components, because some components may have special requirements. For example, you might not be allowed to route traces under certain components, or you can't place pads or mounting holes underneath them, and so on. That's why this need arises. If there are no such requirements for the component, you don't need to draw this area. But if there are, then you must define it. Then we can see that its basic rules are to prohibit routing, prohibit mounting holes, prohibit placing pads, prohibit fills, and prohibit placing packages, and so on. This is also determined by the component's datasheet whether and how to define such an area. Then you select a closed region, and within this region, the rules will take effect. Next, let's take a look. There are options to add different geometric shapes: rectangles, circles, polygons, various lines, as well as text. These are generally similar to what we saw in the schematic diagram, so we won't go through each one in detail here. We'll just briefly introduce the circle as an example. Generally, when we draw a footprint, we will add a circle or a dot at pin 1, so that when we solder the component later, it's easy to identify which corner is pin 1 and avoid soldering the component in the wrong orientation. Next, let's take a look at another key feature: measurements. Since the footprint library requires precise dimensions, we usually measure it after drawing to ensure accuracy. Select Place Measurement. The mouse cursor will then change to the shape of a ruler. What do we usually measure? We check whether the width of the drawn footprint matches the specification. We measure whether the pitch between each pin is correct, and whether the dimensions of the pins on both sides are appropriate, to ensure that the footprint matches the dimensions in the datasheet exactly. If the measured dimensions are inconsistent, they must be corrected. Otherwise, it may not be possible to solder the component accurately onto the PCB in the future. Finally, we also need to configure the properties of the entire component. Click here to bring up the component properties window. First is the reference designator. We follow the same naming convention as in the schematic, so here we name it U because it's an IC. Next is its value. This value is set according to the component, and you can set it as its name. Then here is the footprint name, which we will change to test. Click OK. At this point, you can see that the name on the left has already changed to test. That's all for today's lesson. If you enjoyed this video, please subscribe to my channel for more video resources. Thank you, everyone.